Hello students, Namaskar to everyone. Myself Mukesh Chitpal, Assistant Professor, School of Agriculture, ITM University, Gwalior. So today I am going to deliver my lecture on maxima and minima. Maxima and minima of a function. So suppose you have given a function that is fx, y is equal to fx is your function. So maxima means its value is maximum at which point? Suppose the value of y is equal to fx is maximum when the value of the x in this function is a. So this function y attains the maximum value. So it is called the maxima. And the point x is equal to a is called local maximum point. Similarly, the definition of minima is similar to the previous one. Suppose we have given a function y is equal to fx and it is minima. That means it attains the minimum value of function y. At that function it is called minima. So suppose if the value of x is a, then the function y is minima. Then this function x is equal to a is called local minimum point. So I think you are aware about the maxima and minima. Now the point at which the function attains maximum or minima, the point at which function attains maximum and minimum, that points are called turning points or stationary points. So function y is equal to fx can have more than one maximum or minimum points. Means the maximum value of the function is attained at more than one point, or similarly the minimum value is also attained at more than one point. So suppose the function have the maximum value attained at x is equal to 2 and x is equal to 3. Okay, but the value of y is maximum we get while putting 2 or 3. Suppose we are putting x is equal to 2 and we get the answer of y is 27. And when we put the value of x is 3 in the function and we get the answer 36, then the maximum value is 36. So maximum of all maximum point is called global maximum, and minimum of all minimum points is called global minimum. So here in this case x is equal to 3 is global maximum. Similarly, the numerical problem for the numeric minima is also we can take. Suppose if the value of x is 1 and x is 0, then we get the minimum value of function y. So if we put 1, the answer is 9, and if we put x is equal to 0, then answer is 5. So which one is the minimum value? That is 5. That comes when x is equal to 0. So x is equal to 0 is called global minimum point. Okay. So there is a point that is called a saddle point, at which the function is neither maximum nor minimum. That point is called saddle point. So how we can calculate the function is maxima or minima, that is described under the table. So firstly we have to calculate the first derivative of the function. So you have to calculate the dy by dx. If the answer is and it is equal to 0 for the maxima, and for the minimum you have to do the same step. But when we take the second derivative of this function, if the answer is less than 0, then it is maxima. If the answer is greater than 0, then it is minima. So these are the two conditions for the maxima or minima of a function. So how the working procedure for finding the maxima and minima is described here. So firstly we have to find the dy by dx, then d square y upon dx square. D square y upon dx square is achieved when we again differentiate the function dy by dx. Okay. Now put dy by dx is equal to 0. After solving this, you can get the value of x. Suppose x is equal to a, x is equal to b. So that value is called the turning point of the function. Now suppose your turning point is x is equal to a. Then substitute this value in the second derivative of the function, that is d square y upon dx square. If this answer is less than 0, then it is maxima. If that answer is greater than 0, then it is called the minima. At that point x is equal to a. Okay. So now we have to put the value of x that we have calculated, x is equal to a, in the given function y is equal to fx. That will gives us the maximum and the minimum value of the function at x is equal to a. So this maxima and minima problems we can see with the help of some questions. Okay, we will see a numerical problem that we have to find the maximum and minimum value of the function, that is x to the power 3 minus 3x square minus 9x plus 12. So we write y is equal to, or fx equal to, x to the power 3 minus 3x square minus 9x plus 12. That is given in your question. Now we differentiate this function y, that is dy by dx, and dy by dx we can also write it as f dash x. Okay, so this 2 is multiplied with this 3. Okay, so it becomes 6x. Sorry, firstly this 3 power, we differentiate x to the power 3, and the differentiation of x to the power 3 is 3x square. Then we put the minus. Now we differentiate 3x square, this 2 power multiplied to the 3, and this becomes 6, and x power is subtracted by 1, so that is 2 minus 1, that is 1, so it is becomes the differentiation of x square is 2x, and we write 3. Okay, minus 9, differentiation of x with respect to x is 1, and 12 is a constant, due to that its answer is 0. So now this function becomes 3x square, 3 into 2x becomes 6x, and this is minus 9, so we write minus 9. Now to find the turning point, we have to put dy by dx is equal to 0. dy by dx means f dash x is equal to 0. So we put these values, that is equal to 0, and divide this whole term by 3. So if we divide it by 3, so 3x square becomes x square. 6 divided by 3, that is 2x, and 9 divided by 3, so it becomes minus 3. So now we have to solve this question. So solving this quadratic equation, so we have done this in our class 8th and 9th. So 3 is multiplied with this 1, so this becomes 3. Okay, and we have to find two numbers. So minus 3 into 1, that is minus 3, sorry. So we have to find the numbers whose sum or difference is equal to minus 2, and when the two numbers are multiplied, that will gives us minus 3. So number may be 3 and minus 1. Okay, 3 and minus 1. So 3 multiplied by minus 1, that is 3 multiplied by minus 3 and plus 1. So minus 3 plus 1, it is equal to minus 2, that is given in central point. And when minus 3 multiplied with plus 1, so that becomes minus 3, that is. So we write this x square. So middle term we split. So we write this minus 3x and plus 1 into x, that is x, and this minus 3, that is equal to 0. So minus 3x plus x becomes minus 2x. So what we have done, we have only split the middle term. So from these two, we take x as LCM, and here only x is remaining, and here only minus 3 is remaining. From here, x minus 3 is here, that is similar to this one. So only we here will take plus 1 common. So in bracket x minus 3 will come. So this x minus 3 and this x minus 3 is common. So we write this x minus 3 in one bracket, and this is x plus 1. So we in second bracket we write x plus 1. So that is also equal to 0. So we put x minus 3, it is equal to 0. When we transfer this on the right hand side, so it is x is equal to 3. And x plus 1, that is equal to 0. So when this one goes to the right hand side, it becomes x is equal to minus 1. So these are the two turning points of this question. Now, this is your first derivative of the function. Now we find that second derivative, means d square y upon dx square. Or we can also write it as f double dash x. Again we differentiate f dash x. So we write this 3, and differentiation of x square is 2x. Then we write minus 6, and differentiation of x with respect to x is 1. And 9 is a constant. So due to that its differentiation is 0. So 3 multiplied to 2x, that is 6x, minus 6 into 1, that is minus 6. Now we have to put the two values that we have calculated, that is minus 1 and 3, in this function f double dash x. Now suppose we put x is equal to minus 1. So 6x, 6 into minus 1, then it is minus 6. So minus 6 into minus 6, that is minus 12. So its value is less than 0. That means it will give you the maximum value. Now your function is maxima at x is equal to minus 1. Okay, now we put x is equal to 3 that we have calculated in the previous slide. So we put 6 into 3 minus 6. 6 into 3, 18 minus 6. That will give you 12. That value is greater than 0. That means it is minima at that point. So if we put x is equal to 3, the function gives us the minimum value. Now we start putting these values on the function. So we put x is equal to a in the question that is given to you. Fx is equal to this. So we put minus 1 cube x to the power minus 3. So x is minus 1. Minus 1 to the power 3. Minus 3x square means minus 1 square. Minus 9x means minus 1 plus 12. So minus 1 cube is minus 1. Minus 1 into minus 1 into minus 1. That is minus 1. Minus 1 square. Minus 1 into minus 1, that is plus 1. So 3 into 1. Minus 9 into minus 1, that is plus 9. And this is plus 12. When we solve this entire question, so this is 21 minus 4, that is 17. Okay. 17 is your maximum value of the function. Now we will go to the minima value. So for that we have to put x is equal to 3. So put that value 3 in this function. X to the power 3, that is 3 to the power 3, minus 3 x square means 3 2 square, minus 9x, x means 3 plus 12. 3 to the power cube means 27, minus 3 into 3 square of 3 is 9. 9 into 3, that is 27 plus 12. 9 3s are 27. This is minus 27. This is 12. So this 27 and this 27 will be cancelled because these are plus and minus. Minus 27 plus 12, that is minus 15. So minus 15 is the minimum value of your function. When we put the value of x3, then it will give us the minimum value. And when we put the value of x is equal to minus 1, that will give us the maximum value. So by using this technique, we will solve all the numerical problems of maxima and minima. Now similarly, we will see a second question of this topic and solve another question that is similar to this one. Okay, so find the maximum and minimum value of the function, and your function is given as 4x to the power 3 minus 18x square plus 24x minus 7. So firstly we will write y or fx is equal to this function, then differentiate this function. When we differentiate this function, we will get this function. Now similarly, we put f dash x is equal to 0 or dy by dx is equal to 0. And so then we get this equation and we solve this quadratic equation that I have explained to you in my previous question. From that we will get two values of x, that is x is equal to 1 and x is equal to 2. These are the two turning points of this question. Okay. Now we find f double dash x. To find f double dash x, we have to again differentiate f dash x. When we again differentiate f dash x, we will get this f double dash x. Now we put x is equal to a in this function, and you will get the value minus 12. That is less than 0. Because it is less than 0, so it is maxima at this point. Now we will put x is equal to 1 in the function that is given to you, and that will give you the value to you, that is x is equal to 3. Then we take the second point, that is x is equal to 2. Now we put value x is equal to 2 and we get value 12, that is greater than 0. So it is minima at this point. So now we put the value of x is equal to 2 in the question that is given to you, and you will get the minimum value, that is 1. So the minimum value of the function is 1 and the maximum value is 3. So now from this question you get maximum value, that is 3, and minimum value, that is 1. So I think you are aware, you see this question and you are aware about maxima and minima. So thank you so much.